variable part for the session for solving. Uh, okay, so I would like to recall back for the methods that you have learned in previous topics. Okay, so we start with this chapter or the first course outcome by the separable methods. Okay, separable variable is the first method being used to solve first ODE. Okay, so in the previous video, okay, I have explained about the two forms, okay, for the separable. So the first one, in order to solve the separable, to solve first ODE, using separable variable method, okay, we make it the first form, right? So whatever form or equation for the first ODE, you have to transform, okay, into the first form, or you can use the second form. Okay, so for today, I'm going to explain for the third form. Okay, so I'm going to open the John Bird ebook. Okay, so for today's session, please refer to the ebook of John Bird, page 448. Okay, so the third form in the separable variable, okay, it looks similar with the second one, right? So you can see here. Okay, so the third one, it looks similar. Okay, but the difference here in the second form, we have integration for dx. In the third form, we have integration of fx dx. Okay, so this one, the third form is equal or the same with the second form here. Okay, so only these are different, right? Okay, so I'm going to show and explain the example for the third form. Okay, so problem 9. Solve the equation given for xy dy dx equal to y squared minus 1. Okay, so this is the original equation. So when you see in this problem number 9, there's no boundary value given, right? So means that we need to find the general solution. Okay, solve this by finding the general equation, general solution. Okay, so the original equation, we have to transform it to this form. Okay, so we can see that the original equation is not in the third form, right? So you have to rearrange. Okay, sort and rearrange. Okay, so we see that to make it the original equation to be like this, right? So this for x, and this dx, you have to bring on the right hand side. And then y squared minus 1, okay, you can bring to the left hand side. Okay, so this 4 is optional. So you can set 4 to follow x, or you can set 4 to follow y. Okay, so if we want to, let's say, we want to make it this 4 follow y. Okay, so means that on the left hand side, we have 4y, and then this y squared minus 1 bring to the left hand side. And then x with 1 over dx bring it to the right hand side. Okay, so and then we have like this one. Okay, so I hope you can see how we can transform this equation. Okay, so this one, the step is just to arrange, right? Okay, so let's see whether after we arrange, is it the same thing according to the third form? Okay, is it the same? Okay, it's the same, but we have 4y here. Correct. We have 4y on the numerator. Okay, never mind. As long as y follow y, then x follow dx, right? Okay, so this form is in this, the third form, right? Okay, so and then we do integration, both side. Left hand side we do integration, right hand side we do integration. Okay, so we have this one, symbol of integration. So on the left hand side we integrate with respect to y variable. On the right hand side we integrate with respect to x variable. Okay, so on the right hand side, let's see. when we refer to the formula list, right, integration for 1 over x. So let's see in the integration 1 over x. Okay. So 1 integrate 1 over x, we get this one. Okay, ln x. Okay, so in this ODE, on the right-hand side, the answer for integration, we have ln x plus c, correct? Okay, so in this solving first ODE, make sure the plus c, uh, you add only at one of the variable. Either you want to add at y or you want to add xx. So in this case, you can do the integration on the right-hand side, usually on the right-hand side plus c, okay? So right hand side here is x variable. So after the integration, we have ln x plus c. Now let's see how we can do integration here. Okay, on the left hand side. So we need to do integration with respect to y variable. Okay, so let's look at the numerator and denominator. Okay, so let's look at what is the special method we can use to integrate. Okay. Okay, one way is to choose substitution method. Okay, so choose substitution method, we choose the one that denominator part. U is equal to y squared minus y. Correct. Okay, so I'm going to show uh, the denominator. Okay, so U is equal to y squared minus 1. Okay, so I'm going to write something here. Okay, so U so U is equal to y squared minus 1, right? So this is substitution method. So du, so we differentiate to find out what is the du, first derivative, right? Du over dy is 2y, right? So we have so this dy bring it to the right hand side. Okay. Then 2y dy is equal to du, correct? So du is equal to 2y dy. Okay, remember that in the left hand side just now, we have 4y. Okay. So we have 4y. So 4y, so take it out 2 or factorize 2. Okay, so means that 2y dy is equal to du. Correct? Okay. So now let's go back to the uh our step just now. Okay, so here du equal to y dy, we will replace it into the original equation in the left hand side. Okay, so just now we have 4 integrate on the left hand side. So this 4y over y squared minus 1 dy. Okay, so everything here need to change to du. Okay, so after we change to du, okay, so on the denominator it becomes u, correct? Okay, so we have integration to du 1 over u du. Okay, so now let's see. So when we use substitution method, this form becomes simpler. So here we can do the integration easily. So integrate 1 over u is equal to ln u, correct? Okay, so I hope you can familiar with the methods of substitution in order to integrate. Okay, so remember here. Okay, so here this answer will be 2 ln u. Okay, but then 2 ln u, don't forget to substitute back. U equal to this one. Okay, so your final answer should be in terms of y, not in terms of u. Okay, so the answer for the integration for the left hand side is 2 ln y squared minus 1. Okay, so we go back. Okay, so the left hand side, we have 2 ln y squared minus 1. You can write down also the absolute symbol, okay, for the one in the bracket. Okay, so we have 2 ln y squared minus 1 equal to ln x plus c. Okay, so this is the one in the general solution. Okay, or either another form means that there is another answer. Instead, having the final answer of general solution in terms of ln. Okay, ln means what? Ln means the log function in base e, correct? So you can modify this ln to the exponential base e. Okay, so this is by using rules of logarithm. Okay, uh, 2 ln y squared minus 1, it means 2 log log base e, right? So here you can write down here log ln x as log x base e. Okay, and then remove it. The log means that the log can be changed to the exponential to this one. Okay, so ln is x base e, right? So you can have two answers. In the first answer for the general solution can be written in terms of ln, or second answer for the general solution it can be written in terms of base e, exponential with base e. Okay, so you can choose any one according to the problem. Okay, so that is the step for uh, problem number 9. Okay. Okay, we'll proceed to the problem number 10. Okay, second example for the third form of separable variable. Okay, so in problem number 10, so I'm going to read for you. Problem is to determine the particular solution is given dt d theta over dt equal to 2e power 3t minus 2 theta. And there are boundary values given t0 when theta is 0. Okay, problem number 10 is different. So the notation for first ODE, this is first ODE, right, is given in terms of theta and t. So commonly you are familiar with dy dx. So this time d theta dt. So we do similarly. Okay, so now when we refer to the third form, so it's given here the original equation d theta dt. So your y is theta. So this one need to change d theta f theta. So for fx dx need to change to ft dt. Okay, so we do following the third form in separable variable. Okay, but we do the changes in terms of y change to theta and then x change to t. Okay, so the original equation, let's look at whether it's given in the form or not. Okay, so it's not in the third form, right? Okay, so you have to modify. Okay, modify. Okay, so the first one, we see, look at the this one, 3t minus 2 theta. So our function now is combined, but you have to separate. Okay, if t need to follow t and theta need to follow theta, so in the exponential here, you have to separate. How to separate? By using exponential rules. Okay, rules of exponential. So this one, exponents, separated. Okay, how we can separate it? When the base is the same, this is base E. This is also base E. Okay, now they combine. So separate two like this one. Okay, so when we have two base and the base are the same by rules of exponential, the indices here means that at the power there will be added 3t plus negative 2 theta. So when you combine, it becomes here. Okay, So from the combine, why we do separated? You have to separate according to the exponential 1t and then the exponential in terms of theta. Because in the separable, this t need to follow t. Theta need to follow theta. Okay, so that's why this method is called separating the variable or separable variable. Okay, so the one that I mentioned, rules of exponent, is the same meaning that we call laws of indices. Okay, laws means the rules. Okay, rules of indices, or we can call it rules of exponents. Okay, and then once we separate this one, t and theta, so this t follow t, theta follow theta. So remember that on the left hand side, we make it for theta, the right hand side for t. Okay, so rearrange left hand side t, bring it to the right hand side. Okay, then this e to the power negative 2 theta, bring it on the right hand side here. Original one is on the right hand side, bring it to the left hand side. Okay, so this one is divide, bring it to the right hand side, that is becomes times. So here e to the power negative 2 theta, bring it to the left hand side, it will be e to the power positive 2 theta. Okay, so once we arrange, so we have this one. Okay, so this time, this is 2. So you decide that 2 want to follow, 2 here is the constant, right? 2 you can decide to follow t, or you can decide 2 to follow theta. There's no issue because it's a constant. Okay, so we have rearranged it. So this is according to the third form, right? Okay, so the issues here, on the left hand side, we have function theta d theta. We have right hand side the function of e to the t and dt. Okay, so we do integration. E power 2 theta, integrate with respect to d theta. Okay, can you see that in the left hand side, there is f theta. Okay, the left hand side, there is f theta, 1 over f theta. But your f over f theta is 1 actually. So it's something is divided by 1, remember? Okay, so it means that your f theta is 1. Okay, so it is the same thing as actually. So on the right hand side, this is our ft dt. Okay, compare it. Ft dt. Okay, so it's direct integration. So we have integrate with respect to theta. So we have 1 over 2 e to theta. On the right hand side, integrate with respect to t variable. Then we have 2 over 3 e power 3t. And then plus c constant on the right hand side, plus c. Okay, so since in the problem number 10, the boundary values are given. So we have to use boundary to find out the particular solution. Okay, so this one is general solution. To find out the particular solution, we use the boundary value given. So this is the value. T0, theta is 0. So substitute. Okay, T0. T0. Okay, so this one 3 times 0. So e power 0 is equal to 1. Okay, so here will be 2 over 3 times 1 plus c. Okay, and then substitute theta is 0. Okay, into here. So 2 times 0 is 0. E to the power 0 is 1. Then the left hand side we have half, right? So the left hand side is half. The right hand side is 2 over 3 plus c. Then you can solve for c. And we simplify it. You can verify the value using your calculator. C is negative 1 over 6. Okay, so after we find out the value of C, as the C means constant, substitute back into your general solution. Okay, so the particular solution is half E 2 theta equal to 2 over 3 E 3t minus 1 over 6. Okay, another form of the second equation. This is equivalent actually. There's no problem. You can do the first form of a particular solution or the second one. Okay. Okay, so I have reviewed two example for the third form in the separable variable. Okay, so you can study at the remaining problems in this ebook. Okay, and I hope that you'll be able to complete all the tutorial questions given. Okay. Since these subjects are very crucial, okay, because the understanding in this subject or the basic topics that you learn in this subject will be used later on in other subjects, okay. There is in mostly for the division subjects, okay. So don't forget to complete your tutorial question for this separable variable. And then please always review all recorded video that I have given to you, and please try your best, okay, to complete to complete the tutorial and submit according to the deadline. Okay, so that's all. That's all the for the topics of separable variable. Then please wait for another video for the next methods. Okay, so thank you.